Welcome to our today's lesson. We are going to look at geometry today. But before we start on geometry, what we need to do is that we need to look at our previous lessons homework, which was more of quadrilaterals, calculating the distances, the angles, and all those things. So the last lesson we had only 3 questions on homework, and that's what we need to look at. So we are saying that the first question that we had, we're calculating the area for the last questions. Our last question we had, let me draw it properly. Okay. Okay. We're given that BD is 90. So this was BD. Then this was ABAC. Then I had O and T. All these were perpendicular. Then BD is 90. Then AO is 20. Then TC is 25. So now the question was, calculate the area of this shape. So in this shape, we are calculating the area of 2 triangles. That's what I'm simply doing. We're calculating the area of 2 triangles. Okay? Since we are calculating the area of 2 triangles, I'm calculating the area of triangle ABD. So in other words, I'm saying that area ABD, which is the half base, my base is BD, which is 90, times perpendicular height, which is 20, because it's AO. That is the perpendicular. Then this is 900. That is my answer. Then I'll do the area for BCD, which will be half of 90 as well, times 25. Half of 90, which is 45, times 25, that gives us what? 1,125. Therefore, it means the total area now is 1,125 plus 900. We are adding these two together. Which is 2,025. That is the total area of this shape. That is the total area of this shape. This is what we're given for the first question. And we wanted to calculate the total area. Okay? Then from there, we have question number 2. We're given a trapezium. Then there's another line here. Okay. So this is parallel to this, then this one is parallel to that. To make this one a parallelogram. Then, with a line drawn here, and this was 4. This is 6. This is 7. EC, then B, A, D, like this. Then the question is, want to find the area of this. This was 8. Okay, so we know that to calculate the area of this, EC is the one which is 7. It means this also DE is 8. That's what it means. So I can calculate the area of ABED. And to calculate the area of ABD is area of ABD, ABED. This is just 8 times 4, which is 32. The area of AB is just, the base is 8 times perpendicular height, which is 4. And that is equals 32. That is the area. In other words, what I'm also doing is that if you look at this, I am actually saying that if I cut this piece here and do this, then do this, it's like I'm taking this piece here, then it will become a rectangle, which is 8 and 4 centimeters. And that's why it is just 8 times 4 to get 32. Then the area of triangle now, triangle BEC, is half of 7 as my base, and my height is still 4. So this is 14. The height is still this one, and this distance is 4. Therefore, the total area is 32 plus 14, which is 46. The total area is 32 plus 14, which is 46. So that is the total area of this shape that you are given. So that was question number 2. Then we'll move from question number 2, go to question number 3. So it's question number 3. We are given the parallelogram. Then I'm given K, L, M, N. Then I'm given a line here, which is perpendicular to this, and it's AB. Then I'm saying AB is given as 13, NM is given as 14. Therefore, it means the area of this, it will be the base, which is 14 times 13. That will be the area. Remember, it does exactly what I said in the previous question, that if you do like this, and you do like this, or like this here. So this part that I'm cutting here, I can cut this part here. Then take this part to this. Then it becomes a rectangle. And that's why I can say 14 times 13. Then so if we say 14 times 13, that gives us what? If I say 14 times 13, that gives me 182. And that is your area, 182. Okay. So this is homework from the last lesson, which was about quads that we did. Okay. But now what we need to look at, we need to look at revision of grade 8 geometry. Then once we've done that, with grade 8 geometry, we move on to polygons, we move on to congruence and similarity. So today's lesson, we are focusing mainly on grade 8 geometry, the summary of what we did in grade 8. That's our main focus. Okay, so we'll do examples of questions, we'll do examples of different things. So if you look in grade 8, this is just a summary of grade 8 geometry. So I'll say number 1, was I'll focus mainly on questions and try to summarize these things. Let me say I've got this, and this angle here is 40 degrees. Then I want you to calculate x here. So we are saying that what is the value of x? The value of x in this case, it's 180 minus 40. And what is the reason? We can write adjacent angles on a straight line. Or we can simply write angles on a straight line, but these are adjacent angles. Okay, therefore this is 140 degrees. So x is 140 degrees. You can write angles on a straight line as supplemental, that's fine, or just adjacent angles. That's what we used to do in grade 8. I'm trying to summarize using examples rather than just explaining what it is and all those things. Okay, then the other thing that we did, I can do this. Then I'll say this is 80 degrees. Then calculate x here. What is the value of x in this case? We are saying that the value of x is also 80 degrees. And the reason we said it's VOA, which is vertically opposite angles. X is equal to 80 degrees because of vertically opposite angles. Okay, so I'm saying the value of x is 80 degrees because of vertically opposite angles. Then the next one, example. So I'll say that this is 37 degrees or 38 degrees. This is 38 degrees. Then the question is, calculate the value of x. Calculate the value of x if that is 38 degrees. So we are saying that the value of x is 90 minus 38, which is 52 degrees. And what is our reason? We are saying that they are complementary angles, adjacent complementary angles. Remember, complementary angles add up to 90 degrees. Complementary angles add up to 90 degrees. Or can say angles on a straight line, angles not on a straight line, sorry, on a right angle. They add up to 90 degrees. But there is an indication of a right angle. So if that is at 38 degrees, it means x is 52 degrees. Okay. This is all revision of grade 8. We're just revising the grade 8 geometry. Then I'll say 1 again. Okay, we have this. So I want to say E. Let me say this is F. Then I want to say C, E, F, C, whatever, yes. We want us to explain all this from 40 degrees, which is given. So we should do E, F, and C using 3 different reasons. That's what we need to do. Okay, so we are saying that what is angle C? Angle C is 40 degrees because we are saying those are alternate angles. And we are saying that because of parallel lines. So let me just say AD here, then CD. So I'm saying AB is parallel to CD. Then if I look at E, E is 40 degrees, corresponding angles. AB is parallel to CD. Remember the alternate angles is the N or the Z. That's our alternate angles. Then the corresponding angles is the F. So that's why I say E. So if you look at this, I can say this is my alternate. That's the red, alternate angles. Then if I do this, that is the F. So the red one here, alternate is this and this. That's alternate. Then the blue one, that's the corresponding. Then I have now this green one, which we say co-interior. So we are saying that this is 180 minus 40. Co-interior angles. Sorry, you have to state again the lines which are parallel. AB is parallel to CD. F is equal to 140 degrees, co-interior angles. AB is parallel to CD. And mainly in grade 8, we focus a lot on these co-interior angles. Okay, then example number 2. A 60, 80. Okay? So I want you to calculate the angle A. So we know that A is equal to 180 minus 60 plus 80 inside the bracket, which is 40 degrees. And the reason is that interior angles of a triangle. Interior angles of a triangle add up to 180 degrees, or some of the interior angles, we are saying that they add up to 180 degrees. And as a result, that's why I subtract from 180. Okay? Then, example number 3. So I want to say this is 50 and this is 35. I want to calculate what is x here. I want to calculate what is x. So we are saying that what is the value of x? X is 50 plus 35. And what is the reason? Exterior angle of a triangle is equal to sum of opposite interior angles. So if you look at this, these are the opposite interior of that exterior angle. So it means this is equal to 85 degrees. This is equal to 85 degrees. Okay, then example number 4. Calculate the value of x and y. Calculate the value of x and y. Okay? All this is all revision from grade 8. So if you look at this, what is the value of x and y? We are saying that our x here is equal to 35 degrees. These are angles opposite equal sides. Angles with opposite equal sides. Or you can state isosceles triangle. But when it says isosceles triangle, you have to state which sides are equal. So in our case that the sides are not labeled, you can label the sides yourself. You are allowed to add more information. Then once you label the sides, then you can simply say that isosceles triangle, either AB is equal to AC, whatever the way you labeled the triangles. So you can do that. Then to calculate y now, y we are saying that it's 180 minus 35 and 35, which is 110. And the reason that we are saying that sum of angles of a triangle equal to 180. Okay. Remember that these triangles, all these drawings, they are not drawn to scale. That's one thing that you have to know. So you don't say that y does not look at 110, does not look at 110 degrees. Nothing's drawn to scale. Okay, then example 5. Calculate the angle A. Calculate the angle A. Okay. So you find out that the angle A here, any of these angles, they're all the same. So it's 60 degrees. This is angles of an equilateral triangle. Angles of equilateral triangle. Okay. This is an equilateral triangle because all the sides given here, we are told that all these sides, they are what? They are equal. All the sides of the triangle, they are equal, and that's why we are saying that this is opposite or angles of an equilateral triangle. That's the reason behind we said that. Okay, then question. Another example. I will not look at the properties because we've done already the properties. So I will not look at the properties. We've done already the properties. So I'm just looking at revisions regarding the geometry, calculating the angles. I know we can also add the properties, but it's something that we've done. We are looking at the properties of quads. Okay. Then we can look at some now, because I also want to look at polygons, as I've said, and different things that we need to look at. Okay? So it's more of revising. So with these ones, you can be given a lot of things that, as examples, we've done supplementary. One thing that I didn't do, let me just do this. Example 6. I want to do this. So let me say this is 15. This is 105. This is 40. No, not 40. Let me say 45. Then I want to calculate X and Y. Okay? We know I can simply say X is 45 degrees, which is vertical opposite angles. Then to get Y, if you notice on this, wait. Okay, wait. My diagram, something's wrong here. Because there is no way it can be 45 degrees. So let me remove this. Then let me just say calculate X and Y. So calculate X, Y, and Z. So I can say X is 180 minus 105. Angles on a straight line. So the value of X angles on a straight line. The value of X in this case is 75 degrees. So it means if this is 75 degrees, that means Z is also 75 degrees. Vertical opposite angles. Then what I wanted to say is that to calculate Y, we can use revolution or angles around a point. Or I can use angles on a straight line. So I can say Y Y is 55. Then I can say angles around a point. Revolution. We can still use angles on a straight line. We can still use, besides angles on a straight line, we can still use, what do you call it? Vertical opposite angles. It also works. Okay. So all this will still work. Okay, so these are revision of what we did in grade 8 regarding the geometry. We need to use this for our polygons, which is under geometry as well, that we need to look at. So polygons, we need to look at what is a polygon. What is a polygon? A polygon is a many-sided figure with straight lines. With straight lines. Okay? These straight lines can be the same, can be different, but what we know is that it's a many-sided figure with straight lines. We have two different polygons. We have the regular polygon and non-regular, definitely. So if you're talking about regular polygon, we are saying that a regular polygon, all the sides and angles are equal. All the sides and interior angles are equal, as well as exterior. So all the sides and angles are equal. That's a regular polygon. Then we need to look at these different types of polygons that we have. We have a three-sided polygon. What is a three-sided polygon? This one is what? Equilateral triangle. Equilateral triangle. That's our three-sided polygon. Then four-sided. I'm talking about regular polygons here. So this is a square. But if I don't talk about regular polygons, we have different types of polygons when it comes to three-sided polygon. If it's not regular, we can have also isosceles, triangle, scalene triangle, all those different types of triangles that we can think of. Okay? But here I'm talking only about regular polygons. I want to concentrate mainly on regular polygons. So we have got a four-sided polygon, which is a square, five-sided, which is pentagon, five-sided polygon is, I'm not going to do all of them, it's pentagon. Then six-sided hexagon. Remember that they can go to many sides. Okay, so we know the six-sided is hexagon, The seven-sided is heptagon. Some they call it septagon. The seven-sided, it's heptagon or septagon. Then the eight-sided octagon. So I'll just go up to 12 because those are the most likely used. Eight-sided is octagon. Nine-sided it's nonagon. Then 10-sided is decagon. Then 11-sided, we can go, as I said, even to 20-sided polygon. These are all regular. I'm talking about regular polygons. I'm talking about regular polygons. So 11-sided regular polygon is undecagon. Then we have a 12-sided, which you call it dodecagon. Okay, I'll go up to here. But as I said, you can go up as many as you can, but I'm going up to here because normally, test exams, we normally go up to, in most cases, up to decagon. The hexagon, heptagon, somewhere there, octagon, nonagon, decagon. We normally don't go up to even 11 or 12. They can say 15-sided, but they're not asking you what the name is it. In most cases, when they say, in this case, that one, they will say that given a pentagon, and you have to know that a pentagon is 5-sided. Or given an octagon, and you have to know that it's 8-sided. But normally when they give you more than this one, they will tell you that given a 20-sided, they don't expect you to know the name. Or given a 25-sided regular polygon. Okay, then we have what we call concave hexagon. Remember a hexagon, we said that it's a 6-sided shape. Or if we talk about a concave polygon, actually, the concave polygon, we are saying that it's curving like inside. That's what we can call it concave. Whereby it has got one, let me say that concave. I'll give an example here. I can say this is concave because of this angle here, which is curved inside. That's concave. Then we have also convex, whereby it's like this. That's convex. So you find out that with concave, there is one angle, sometimes or more, curving inside. This, then convex, everything. We are saying that that's convex. It can be, in this case here, I have 1, 2, 3, 4, 5. So in this case, it's a pentagon. In this case here, 1, 2, 3, 4, 5, 6. It's a hexagon. But it does not mean that it's regular from what I'm saying here. Unless if I indicate that they are regular polygons. Okay. So we need to look at how do we calculate the angles. How do we calculate the angles? Now, you find out that to calculate, I would rather do this. Number of sides, I want to draw a table here. Actually, let me draw my table here. Number of sides. Then I want to have number of diagonals. And okay, let me leave number of diagonals. Triangles, number of triangles. Then sum of interior angles. So I'm doing like this. So if you look, for example, a triangle here, which is number of sides, there are 3. If I'm drawing a triangle, you find out that it's only one triangle that I have. And the sum of interior angles of a triangle, we all know, it's 180 degrees. If I've got a 4-sided polygon, number of sides, that's a 4-sided polygon, you find out that if I draw the 4-sided polygon here, if I draw the diagonal, it forms 2 triangles, which means the sides of interior, which means this becomes 2 times 180. And that's why a 4-sided shape has got 360 degrees. Then if it's 5-sided, I'm talking about the pentagon now. One, two, three, 4. Then I'll do this. 5. So you find out that this can be divided into 1, 2, 3 triangles. This can be divided into 3 triangles. So this is 3 times 180. Okay. So in other words, we are saying that the number of sides, if there are n, you find out that this is n minus 2. If there are 3, it's 3 minus 2 is 1 triangle. 4 minus 2, 2 triangles. So it means here, it becomes n minus 2 times 180. That is the sum of all interior angles of a polygon. So I'm writing here, sum of all interior angles. Sum of all interior angles of a triangle. Not of a triangle, of a polygon. It is given as n minus 2 times 180. This is, I'm talking about, so we are saying that the number of sides of a polygon, the number of sides of a polygon, then it's n minus 2 times 180. Then I can get the sum of all the interior angles. Okay. Then the size now of each interior angle. Size of each interior angle of a regular polygon. It will be equal to n minus 2 times 180 over the number of sides. Because you are saying that if all sides are equal, if it's a triangle, we say that it's 180 divided by 3, which is 360. Then if it's a four-sided shape, we say 360 divided by 4, which gives us 90 degrees, going on like that. So if all the sides are equal, if it's a regular polygon, we are saying it's n minus 2, 1/8 over n. Remember that the sum of the interior angles of a polygon, it does not matter whether it's regular or not regular. But if I want to get the size of each interior angle, but only of an regular polygon, that's why I divide the number of sides by n. Okay. Then we have also an exterior angle of this polygon. Let me draw a triangle here. Then if I extend this, this is what we call exterior angle. Okay. So we are saying that an exterior angle, irrespective of the number of sides, it's always 360 divided by n. 360 divided by n, which means I can also say that the interior angle as well, it's also the same as 180 minus 360 over n. I can write also this interior angle is also 180 minus 360 over n. That's the size of each interior angle as well. Okay, so this is what we have to know on this. Then we'll look at different questions and in our next lesson. So this lesson was more of revision of polygons. Not only of polygons, because polygons that we've never done them, but we revised more of geometry, grade 8 geometry. That's what we're doing. And also doing our homework and discuss about the polygons. Okay? That's what we're simply doing. So now I can simply say that this, for today, I'll stop here, go and revise these things. Then we'll start with work and homework on polygons in our next lesson. Thank you.